Today we're going to look at some review items in order to calculate fraction. So this is our fraction review. So let's warm up with some items that are going to be important for us as we are adding and subtracting this year. So we'll spend a couple days reviewing these. And the first one would be factors. Factors are numbers that are being multiplied in order to get a multiple. So if I gave you any number, for example, let's say 12, the factors of 12 would be the numbers that end up equaling 12. So I like to call this method like a rainbow style because it makes me think of both factors that would equal 12. So I know 1 is a factor of every single number because 1 times anything is itself. So I know 1 times 12 is factors of 12. They equal 12. Now, and then I just keep going from 1. So is 2 a factor? Yes. 2 times what? 6 is 12. So see how it's kind of going together? It's 3. Yeah, 3, because 3 times 4. And as you can see, I'm starting to like close in this gap. And then I know there can't be any other number that equals 12. So these are all my factors. 1 and 12, 2 and 6, 3 and 4 are all factors of 12. So let's do another one. Let's do 24. 24 is a bigger one. There's a lot of factors of 24. So if you use your basic fact knowledge too, this will help in knowing some of the options right off the top of your head. But always starting with 1 and ending with 24. Because what equals 24? Factors of 24. Okay, so 2. 2 times what? That would be 12, right? And then does 3 work? Yeah, that would be 3 and 8. Oh, it's 4. Yeah, 4 and what? 6. Our only other options are 5 and 7. 5 and 7 equal 24? No. So I know I'm done. I have all of the factors of 24. So it's interesting if you wanted to have two numbers and find a common factor that they can both be divided by, because all of these factors can divide these and get the other factor, right? So look how many common factors that 12 and 24 have. And you can even find something that's useful for fractions, the greatest common factor, and their greatest common factor is 12. So you can see all these common ones and see that, okay, that the greatest one is 12. Okay, so that's factors. Well, what about multiples? So multiples is kind of like reverse. And multiples are what are the answers to factors being multiplied together, right? So if I wanted the multiples of 6 and, let's say 8, I'd be listing everything that when I multiply it, what it equals. So 6 times 1 is 6. See, I just multiplied it times 1. And then 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. We could go on and on and on and on because there's an infinite amount of numbers that we can multiply by 6. But I always like to start with thinking about the first 5. So it's always good to know those basic ones. So 8 times 1, getting all the multiples are 8. 8 times 2, 16. 8 times 3 is 24. 8 times 5 is 40. 8 times 6 is 48. So we can see the list of multiples. So it's kind of reversed, like I said. We're taking all the pieces that equal when it comes to factors. And then the multiples is like the answer. What the multiples is what we're actually getting if we multiply the factors together. So what we can also do with multiples that's helpful with fractions is find ones that are also in common. And sometimes what's also best is the smallest one in common. So 8 and 6, they have 24 in common. Now you can also even know that, okay, so we did this one times 3, times 4, times 5. If I kept going and I did times 6, I would actually get a 48 matched up with the 6 and the 8, because 6 times 8 is 48. So I would have to keep going to times 7 and then times 8. So I don't really need to keep going with 8 because I already have the times 6 one. And so times 7 for the 6 would be 42, and then you can see I do get to 48. So while 48 is a common multiple between 6 and 8, the smallest one is 24. So that is helpful to know that least common multiple when we are working with fractions. All right, so that is factors and multiples. The next thing we're going to look at is improper fraction in mixed numbers. So if I have a part of a whole, let's say these two pieces are the same size and they're cut into the same amount. If I had this many, how would you write this as an improper fraction? So the first thing would be important to discuss is what makes a whole? What are the parts? And then what makes a whole? So when we're talking about a fraction, we have a numerator, and then we have the denominator. And the numerator are the parts, or you could even say pieces. And then the denominator is what makes a whole. In this particular image, how many pieces make a whole? Well, we're not going to count all of the pieces because this is a whole and this is a whole. So what made it a whole? 3. So our denominator has to be 3. Okay? And then how many parts do we have total? 1, 2, 3, 4, 5. 5 parts. This is an improper fraction because the numerator is larger than what makes a whole. This means I can make a mixed number. The mixed number is taking those parts and showing them as a whole number and any fraction pieces left over. So if we look at our image and still thinking, okay, I need parts and wholes, I can do a whole number. I see that there is one whole, but there's still some parts left. There are 2 pieces of 3. Okay, 2 out of 3. Another way to think about making improper to mixed is that we can know that this fraction is a fraction bar is a division sign. So it's the same thing as 5 divided by 3. And we know 3 can go into 5 one time. And there are 2 out of 3 left over. So see how that translates into a mixed number? We can do a little bit with a mixed number as well. So we know that here a whole is 3 over 3, right? And then we still have 2/3 left over. So this is that whole, and then 2/3. What improper fraction does it give us? 5/3. So we can see where 5/3 comes from now too. Okay, so improper to mix makes the improper, demonstrating those different parts of wholes in different ways. Now, we always want to work with our answers when we're calculating fractions in mixed numbers because this is how we function with them in real life. We are not looking at improper fractions because we can make them into whole numbers. All right, so that's it for our quick review. Now we can practice and prepare for calculating fractions.